জয়েন করতে। এখানে 42 পার্টিসিপেন্টস জয়েন করেছেন।
গুড মর্নিং ম্যাডাম।
গুড মর্নিং। আই এম সরি, আমি একটু দেরি হয়ে গেল আমার জয়েন করতে আজকে। Around 42 participants have joined. একটু ওয়েট করে যাই 2-3 মিনিট। হ্যালো
হ্যালো।
হ্যাঁ, আর 2-3 মিনিট ওয়েট করে যাই, আরো কয়েকজন জয়েন করে নিক।
ঠিক আছে, ঠিক আছে।
Mr. Angshuman Chakraborty, have you shared your screen? Is it all right? No, network problem আছে কিছু।
Yeah, I have just been logged out. I'm trying to log in again.
Okay.
Right.
Audio.
Ma'am, am I audible?
Yes, audible.
Okay, thank you.
স্ক্রিন তো শেয়ার করে নে।
না, আমি এখন শেয়ার করছি না। হ্যাঁ, করতে পারবো।
ঠিক আছে, আসছে।
There's some echo is coming from your end.
I think I should leave the session. Okay. I think it's okay now. কথা বলো।
Yeah, এখন তো it's not yet started.
Yes, visible now. So around 50 have joined. Let us start, I think. Otherwise, let the participants slowly join one by one. So I welcome you all on the 5th and final day of the workshop on artificial intelligence and applications. In today's workshop, we have 2 lecture sessions. In the first lecture session, the deliberation will be given by Mr. Angshuman Chakraborty. I would like to briefly introduce Mr. Angshuman Chakraborty before I invite him for the deliberation. He is a goal-oriented software developer with 10 years of experience, with more than 10 years of experience in modular coding and design practices, providing in-house quality research systems and client products in a premier electronics and computation R&D organization. Adept at developing software for desktop computers and Android phones with knowledge about web technologies. He is accustomed to open source tools, technologies, and current development practices. I now request Mr. Angshuman Chakraborty to please start his deliberation.
Okay, thank you, ma'am. আপনি দেখতে পাচ্ছেন কি ওখানে?
বন্ধ করে দিয়েছি, ইকো হচ্ছে বলে মনে হয় দেখাই যাচ্ছে। আপনি জিজ্ঞেস করুন।
হ্যাঁ, sure. Good morning, everybody. And myself, I'm Angshuman Chakraborty. And is my presentation visible to everybody?
Yes, presentation is visible.
Okay.
There is a
So
to-do screen.
yeah, now it's
Yeah.
not there.
Mhm.
So we will be discussing how we are using vision in AI for robotics. So we will get started. So we are basically our focus is first of all I'll say why AI is required in robotic vision. So basically it's a robot. Robotics is the design. We are basically constructing a machine that can mimic human behaviors. They can do our task, and okay. So they have to be precise and they have to be intelligent
Uh,
like us.
if you could please
That is what we expect.
speak just nearer to your microphone, a little bit
Okay.
louder. Yes.
Okay. Okay, right. Is it fine now, ma'am? Is it
Yes.
fine?
Yes. Fine.
Okay. Uh, so, uh, so our main objective is to create a machine for that will do our tasks that we consider very risky, or that is not always possible by humans, like say monitoring. So in those scenarios, we might use vision also, because it's a sensor that gives a very useful information, and if we can use that vision information, we can no, we can do a lot of tasks. So when we are using a vision, we need to one particular one of our objective is that we should be able to identify objects or patterns. So that was our task. That was a challenge, and in that attempt, we we explored GLCM and HAR Cascade, and like we were exploring. I mean, got stuck, or we encountered some disadvantages. So we kept on exploring, and we laid our hands on the CNN. And once we started working with CNN, we found that it was giving a pretty good result compared to the other technologies. So basically, we will be discussing about CNN, why we have used CNN for robotics, and to identify objects and patterns. Okay, so why CNN? Okay, so one of the very good um, observation we had with CNN is that we need very less pre-processing, whereas for HAR Cascade and GLCM, we usually had to spend numerous man hours, whereas that was not the case with CNN. So that was very good for us. We really want that. And another part, and this and CNN, when we started working with CNN, we found that this CNN is very suitable for spatial analysis, that is data spread over a large area. So we can calculate, we can find out features. Okay, we'll talk about features later, but that is how CNN was very useful for us. So we'll go ahead, and this is another aspect. When we had the intention to work with large images, and even worse, when we wanted to work with streaming images of large resolution, well, other technologies were not really scaling up. So we wanted something that could scale up, and we could work with huge larger data. So this is what we are saying, that once we start working with the computation, when the images are large in size, it gets computationally intensive, and CNN has this feature where it can scale down or reduce the size of the image, and pick up only those no or pick up and retain those parts of the image which are basically relevant, and it can discard the I mean it will discard the non-relevant parts. So that was a very big requirement for us. So so this is the basic very fundamental approach we taken. Now we are basically trying to get into a CNN, how to work with CNN. So we had different types of data. We know what to identify. Like for example, I'll just give a very known example, possibly, so that you can relate to other lectures also. Say cats and dogs. So I know this is a cat and that is a dog, and I can have 10 different positions of cats from different angles and 10 different positions of dog from different angles. So we know that these images are for cats and those images are of dogs.
Sir, images are not visible, sir.
My presentation is not visible.
To do slide is just now visible, sir. To do
Okay.
transfer learning, all the list only.
Right now I am in image training using neural network. This is not
No,
visible.
sir. No, sir. It is a red highlighted to do page.
Okay. I'm, okay, I'll try to reshare my presentation, right?
Yes, sir. Share the screen. It's the first
Okay,
option.
right. Now is it visible? Okay.
Yes, sir. Robotics. Yes, sir.
Now I'm okay. Just a second. I'll do once more. It is. Okay. Now let me try.
Sir, it will be good if you share the first screen. Yes, sir.
Right. Now can I? Is it visible?
Yes, sir.
Image
CNN training. Yes,
training.
sir.
No, like my screen. What is like image training
Image
using neural
training
network?
using neural network. Yes, sir.
Right. Fine. Okay. So I suppose you didn't see my previous screens. This was my previous screens. So why AI is required in robotic vision? So I'll share this presentation. So maybe you can get back to this slides. So I have discussed why we are using CNN. So these are the resolutions part that I just talked about, and now I'm talking about the basic approach or the fundamental approach. So basically now this left part train known data. Basically, it is those cats and dogs, those images kept separately, and we know that which image is of cat and which is of dog, and we will also input the expected output, that is basically the CNN training module. This model should be able to identify the cat as a cat and the dog as a dog, and if it fails it will try to correct the error. So and that process will continue until unless a fair amount of correctness is or accuracy is achieved. So after that, we have a model ready. Now we will use that model for identifying an unknown image of maybe a cat, maybe a dog, from a different angle of maybe a different size, color, whatever may be that thing. And we will expect our model to correctly identify that image. So that is the prediction. So this is a very fundamental idea. So this is our task was like we were working on Paddy Blast, and this was another image. I mean another disease. So we started off with at least two disease classification. We'll see that next. So our approach was that we will classify these images separately. So we'll have two different classes, and we will label them, and we'll tell our model that I'm providing this many images of say of one type of disease, and of say another n number of images of another type of disease, and train it. So after the training, like we seen in the previous slide, we'll get a model, and we are ready to use the model. So now I move on to the next part. So we have a healthy paddy and paddy blast. So at least we are trying to identify these two classes, and we will use a neural network to classify these images. Now we'll move ahead. Now, basically, now we are basically moving on to CNN. So CNN is basically it's a class of deep neural network, and we will be using it to identify or solve our problem of identification of paddy blast, healthy paddy, and we have intention to identify other diseases as well as other uh, like other plants. So that is why we had one disease and another leaf, and fortunately we find the disease on the leaf. In subsequently, in further when we enhance, we can enhance into, we can classify more different types of diseases and more different types of leaves. So that was the intention, to keep different two different types of classes. Now I'll just mention this has like nothing to do much with this one, but this is a very good reference. Like we have very good architectures. You will definitely find very good interesting information regarding this. That is VGGnet, ResNet, that is residual network, dense net, inception net, and exception net. So they provide a lot of insight into CNN architectures, what people are working, and which models or which architectures are giving us very good results. But each of them has their pros and cons, but we will not be discussing them. We will discussing something fundamental. Okay. So now we are talking, we are starting off with, say, neurons, or in when we go ahead and find the find you know, we will find very lot of articles, and each of them they are using different terminologies. So in my slides, I have tried to consolidate all of them, so that any of you who will be going through my slides, you can find, if you go through this slide, maybe you can relate to all of them. So this neuron, node, or unit, they are basically the same thing. They mean more or less the same thing. So it's basically this one unit of computation, or some basic unit of computation that is performed. And that is what is known as a neuron. And its basic purpose is to take some input, take input from something, which can be from some external source, or maybe from previous nodes, and then it will perform some calculation, and then it will give some output. So that is basic job of a neuron, to perform some calculation. And here are a few examples I'll give of neurons. That is of dot product of input and weight. We will definitely see that. ReLU, that is rectified linear activation unit. The name itself has the word unit. That is, therefore, this is also a neuron. Bias is also a neuron, although I have specifically mentioned it because maybe maybe it's kind of confusing, because maybe at some time it's basically a constant. So we might think that it is not a neuron, but it is also a neuron. And we have a diagram here in the bottom left, bottom right. So we can see that inputs are x1 and x2. So there are weights W1, W2, which will be multiplied with each of them, which of the input. and there is a bias which has a value 1, and that will be added, and then we'll get an output. Now the details we will see in further slides. Right. Now the next important term that I want to talk about is weight and bias. Weight is basically, I'll just read it out. It's a very good um, kind of statement. Weight is assigned on the basis of relative importance of other inputs. What this means is there will be, when we go further, we'll see that there will be, say, around 9 values, for example. Now, each of those 9 values does not have the same importance. How can we will be using weight to add some importance to some value, and so in that attempt, what we are basically doing is we are enhancing or emphasizing some values in those in 9 values, and we are suppressing others. So the use of this weight is to basically our main intention possibly will be to bring out some value, and when we accumulate all those enhanced values, they will be describing some features which we will definitely see. Now the bias part is basically, I'll say that this is an equation. It's a very known equation, y equal to wx plus b or y equal to mx plus c, is basically an equation of a line, straight line, where m, or here w, it defines a slope, and here w is the weight. I'm just correlating those two equations. So it's known that if we do not have that constant part, where or this bias part, then the line will pass through the center. Now, if we are trying to figure out a feature, that feature it will basically line. If we are plotting it on a graph, a very small feature, it will be represented as a line. Now that line need not always pass through the center. So to mimic that, we need to add a bias or a constant so that the line shifts. So if the line if we are able to shift the line, then we can plot, we can basically mimic or make the line go through or connect all the points of the feature. So that is one reason why we are using a bias. We that is a justification why I need a bias. Another justification is also there. If you see further down the slide, when we might encounter a slide where we'll see that we are providing inputs. The inputs need not always have a they can have values, all of them can have 0 value. So what I'm trying to emphasize is, if my inputs are 0 and if I don't have a bias, that means my y value will be 0. That is, input is 0, the output becomes 0. Now if we are using this in a neural network, that means what comes in is what system is failing to learn anything. Hello, am I audible?
Yes, sir. It is audible, sir,
Okay.
but if it can be some bit louder, sir.
Acha, I'm trying. Okay.
A very bit louder, but it is okay, sir.
Okay, fine. I'm trying.
Yes, it is fine, sir.
Okay. So now, so that is another justification why we need a bias. But that is only a justification of its existence or use. We are free not to use it. If if I know, or if we can determine that we can move ahead without a bias, we are free to do so. So that is why I need to why I told you that this is we have this is a justification. So now we'll move ahead. Now we'll see what are layers. These are very basic fundamental terms we need to know before we move ahead into further slides. Now layers are basically when these nodes they are put together into layers. So what it basically means is we have in neural network in particularly in CNN there are numerous computations that we need to perform, and all of those different computations have different purposes. So it's basically we are it's basically we are categorizing them into purposes. So there will be some layers which will have some nodes or computation units which will perform something, like we can see here. For example, input layers, their main purpose is for input. There are other layers like hidden layers where, like for example, there will be some computation like ReLU or activation or pooling. So they have different purposes. So basically we are putting different computations into different layers, and that is the reason that gives a purpose, or I can even say that we might replace one function, one layer. I mean, the layer will be there. We will replace one by another. Like we can replace a sigmoid or tanh with a ReLU. So that is the thing. So that is where it is layers. And then the computation, or after the computation, we have the output layer. So this output is also a layer, and this output will become an input for the next subsequent layers. Right. So parts of CNN, basically it's two parts. One is the convolution operation layer, and the other is fully connected layer. The convolution layer is basic. Uh, the core part, the gist part is we use it to identify features. Whatever be the layers in between we use, whatever be the different computations we use, but the main purpose is to identify features. Right. And fully connected, like, okay, and before I move to that, there can be numerous convolution operation layers. Right. After that means each convolution operation layer will perform will extract some feature. So if I have 5 different convolution layers, so each of those layers will extract features at different granularity. And then finally, we need to map all of them. So that is where the fully connected layer is we use fully connected layer for that. We'll see further what and how we use them. Okay. Now we will actually subdivide convolution layer, convolution operation. So we find that in this convolution operation, we have three parts or three layers actually. One is the convolution itself. So this extracts high level features, and then once they are extracted, the output of that convolution layer is feature map. So what we find out from this layer, what we get out of this layer, or what this does is it basically identifies the edges, the colors, the gradient orientation. For example, if I relate it to our cat and dog, or if to our to a blast, paddy blast, or a paddy leaf problem, it will identify the different textures in the leaf, the different textures in the paddy blast disease, where there are different there are like, for example, it might be easy for me to explain for a cat and a dog where the ears are pointed. So that pointed thing, that shape is also present in our paddy blast, in our paddy leaf. So those images, those features are present there. So that is how we can this helps us in identifying the features. So that is the job of the convolution layer. Now, after that, we use activation. Basically, we will see that it is its main purpose, maybe the way I see it, is to discard the negative values. We don't have any purpose of those negative values. That that means the convolution layer, in the convolution layer, negative values will be generated. That is, the feature map will have negative values. Now, fine, that operation was fine, but do we need to carry forward those negative values? Well, they are not required. We basically, it's good that we get rid of them. So we use activation. I'm I should tell you that I'm specifically using ReLU. So that is why this is really relevant for that. For other activation layers, uh, we have different approaches. We might not like we might not discard the negative values, but because we get good result with ReLU, so our main objective here is to discard the negative values from the feature map. Fine, but up to this part, the size of the feature map is same. It's not decreased. Now we have already said in the initial part that CNN scales or is very helpful when we have huge size of data. Now we are coming to that part, pooling layer. Pooling layer is that is like the job of this layer, or we use this layer. One of these purposes is definitely downsizing. All right. Okay. Now, when I'm downsizing, that means when I'm discarding values, making the making it a smaller value. Like if I have, say, 1,000 values, if I scale it down, that means I will be losing some values. Now, the next question is, are we losing important values? So that is the point. We are not losing important values. That means basically we are not losing important features. Rather, we are discarding the less relevant features and retaining the dominant or the predominant or the main features. We are retaining them. So that is what we are really interested in. We really want to work with the main predominant features and discard the other ones. So pooling is that layer which will retain only the relevant dominant features and discard the rest of the
Hello, sir. Your voice is not audible, sir. Hello, Ansuman, sir.
hello.
Yes, sir. The video was stuck and your voice was not coming, sir.
Okay, so
Yes, sir, yes, sir. And now
this
it
is
is visible your video and so please
okay.
reshare the PPT, sir.
Yeah, I'm sharing my PPT again. This is not the one. I'm sorry. Okay, now convolution operation slide is visible.
Yes, sir.
Okay, like did you miss something, or this is the slide where we left off?
So only few seconds it was delayed, so 30 to 40 seconds. Yes, sir.
Okay, fine. Okay, so that is the thing. Like that is the reason why we use pooling. Main intention is to retain the important features. The fallouts are very good for us. Downsizing, right? So subsequent layers will definitely use this reduced size and will only work with the relevant features. Now, after that, the next part after this convolution operation is the fully connected layer. We will be basically connecting. We will be like, okay. Now I said we have there will be numerous layers, convolution layers, each of them generating features. So fully connected layer will create a kind of a vector wherein it will connect all the features. Like for example, I'll go back to this cat and dog example. The entire year will be mapped, right? So the initial convolution layers will identify the very small parts of the year, and the subsequent layers will identify the larger parts of the year, and those images or those layers features will be connected together into a single fully connected layer, so that when a new images unknown images image is fed into the network, our network should be able to identify that this is a cat's ear or a dog's ear. So that identification, to happen that identification, we need this fully connected layer. Right. So the objective of fully connected layer is to take the results of the convolution or pooling process and use them to classify the image into a label. So that is the thing. It will give us the result as a label. That's a cat or a dog. Okay, so this has basically three layers. One is flatten. Flatten is basically, I should tell you that in all along our discussion in the convolution operation, we had basically all the outputs were say two-dimensional. Fully connected in this flatten layer, it will make it one dimension. So that is the first part. Second part is it will there is some few more weights to assign, so that the I mean so that the feature can be like I would say the feature is predicted correctly possibly. And finally we'll see that this output layer, it will give us it will give us correct it's not correctly, it will give us a prediction. Whether it's correct or not, that is the next question, right? So I'll just move to this next diagram. This is basically whatever we have seen. It's a diagram, a representative diagram for easy use. So the left part is convolution operation and the right part is fully connected layer, right? Now there are a few more ideas. Okay, this is a forward pass. I'll just summarize the very important aspects which are required for us when we develop our network model. It's a forward pass. Basically, we are basically I will say that it's a convolution operation. We are when we are we'll see the convolution operation in details a little later. So it's a convolution operation where so that entire convolution operation is basically will that's a part of the forward pass. Its output is its input is possibly a two-dimensional array, and it also gives an output of two-dimensional array. So, right. So we'll see this. Will not okay. We'll not see this. We'll see this convolution, but not the full pass. We'll just see an effect of the forward pass. So this is basically a convolution operation. You will find a lot of um, diagrams regarding this. Basically, the central matrix is a filter. It's a filter. We can call it as a we'll call it as a filter. Okay, right? And we have this input. The left pink color is a in it's a input. It basically will start from an image. So image has numerous. It's basically a matrix. Image is nothing but a two-dimensional matrix with three layers if we are using RGB. So right now, say we are just a very simple diagram. So we have the input of say any one of the layers, and we have a filter. We are basically doing a cross product, and we are getting some values. See, in the output we have negative values like I said, and we if we are using an activation like ReLU, we'll discard. We don't want those negative values. And this sharpen filter, if you see you will find that all the border, this is just an example, although all the bordering areas they have -1 value, and the central part it has a positive value which is 8. That simply means that we want to emphasize certain values which is at the center. The peripheral values, we are not much interested in them, so we are basically suppressing them. This is just an example, but this is how our kernel or filters can be. And the values, they are nothing but the weights. So that is what we have learned all along. Now this is just a little bit bigger diagram of the same thing we have seen. Is an Here we have RGB channel. Say from the in left two-dimensional matrix, the three, maybe you can say RGB. So those are the inputs. The filters, we have I just want to emphasize that the filters have a size of 3 by 3, and again another 3, that is for 3 channels. Okay, and now they are convolving, and we are getting some value in the output volume. That is the value of these 3 will they are being added, and we are getting the value. So this is nothing but that same diagram for RGB value. So what I want to mention is, if we have say a grayscale image, we should work with one filter. If it is 3 channels RGB, then we should work with 3 filters, one for each. Now this is just that's same diagram in one another way. This gives a very good visual clarity. So possibly now you can see that they are convolving, and we are getting some value, and then the output, they are added. That is what I was talking about. And one more thing to note is that the kernel for the same image for RGB, the kernel values are different. So that is a point to be noted. Right. So now we are moving on to kernel. So we use the term coordinates for convolutional networks. We use kernels to extract features like we have already said. We are using weight and bias to associate importance. We have discussed those things. And these kernels are good at learning features. Right. Now, multiple layers of convolution networks are used. We have already discussed that. And I'll just repeat it once more, that initial layers will identify finer details, lower level details, and higher or further down the higher number, the lower, the initial layers will identify finer details, and higher layers will identify high details. That is the way it is, because the higher layers use to identify higher layers, more computation resources required. Okay, conventionally, the first is responsible for capturing low-level features. So array layers will capture higher level features, and together they give a wholesome idea of the entire image. So this is again another example, or an example of kernel of filter. So I'll not go into this, but this is basically the same thing we have used. Right. Now again, after this, after the convolution operation comes the activation part. Now it's a little bit details. It normalizes the input. That is what we are saying. That is, it will basically it will make my model a little bit perform better, because we are discarding some values. So we are using this, we are using particularly ReLU. So where there is, I mean, you can see two functions, say y equal to max 0 or 0 and x. So if we give x, and if x is 0, if x is negative, it will give 0. And if it is positive, it will give the value x itself. So that means, see in the rectifier plot, so for all 0 values, for all negative values, this is all 0. For higher values, we get the same value itself. So nothing but we are replacing the 0. Next comes is the pooling. Is basically we are reducing the size. Now, few other things to consider here is that what if my images are shifted laterally in any other direction? Well, our pooling layer has an inbuilt feature, kind of, I can say, wherein these lateral shifts can be taken care of. It takes care of the lateral shift. Excuse me, am I audible and visible? Arey. Hello. I'm sorry. Am I visible now?
Sir,
Am I visible now?
so you are visible, sir.
Okay. Now I'll share my slide. Okay. So now my slide is visible. Pooling slide.
Yes, sir. Yes, sir.
Okay. Right. Now the pooling layer, it's basically position invariant is the thing that I want to emphasize. That is, if my while if the same dog is shifted a little bit left or right, or above or below in the image, it does not really matter. Our algorithm will work fine. But we need to. It is also that it's this shift invariant is basically it works for few pixel shift only, right? Now we are using max pooling, and it is basically it it is like it suppresses the noise, that is discards the unknown or unwanted images or unwanted values of the images. Now, just a code snippet. We are using Keras for our application. We have, so this is just a code snippet. Here, I just would like to emphasize few things that we have you or we can use. I mean, we should define the number of filters or kernels and the size of the kernels. We can, and one more thing, we can work with a lot of default values. So the kernel how they are initialized with what values, we may ignore that, but if we want, we definitely have control over that also. And the filters usually are powers of 2, that is either 32 or it goes to 64, so it's power of 2. And then the kernel size, they are all multiples, they are all tuples with multiples of odd numbers. And okay, so there are other parameters we'll see a little bit later. See, like we have other parameters like strides and padding. Stride is when we have performed the convolution, how many steps should the filter move on the image. So if it's just a one shift to the right or one shift to the bottom, that is, it's a 1 by 1. If it is 2, then it is 2 by 2, or if 2 by 1, whatever we want, we can do that. So that is a stride. Padding. Now, padding is basically, see, if I have a filter of size 3 and an image of size, say, 10 by 10. So that means if I'm convolving this 3 by 3 on a 10 by 10, there is one pixel that is left on to the right. And also I should say, if my stride is 2, then we need one more, we are short of one pixel to the right. So in that case, we need a padding. So we can provide, if so that is basically the padding. So if I am short of some pixels, those pixels can be added to the image, because there is a issue with the slides and the size of the kernel. Right. And okay, so now we'll talk a little bit of about back propagation. See, for most of the work we do, uh, hello, am I visible? Hello, तो network
Yes,
आ
sir.
रहा है. Oh, okay, am I visible?
Yes, sir. Back propagation slide is now.
Okay, actually, it was. Just a second. Okay, so backpropagation, basically, most of the time, possibly will not. We do not. We just need to know the inner working. We do not usually need to work with or control that. So basically, see, like I said, I should tell you one more thing, that while working, while working, we start with some initial value of the kernel, and then at some point of time, I mean, those values of the kernel are not always, they're definitely not the right values. Those values are the weights, and they need to be trained. I mean, this is the in the training process, those weights are updated. So to update that, I mean, first thing is, why we need to update that, because there is some errors in that. What is the error? Those filters or those values are not basically able to identify a feature of the from the image. So there is an error. We are basically calculating the error, and though that error value is back propagated into the neural network, to, back to the initial layers from where it started. That is, that means now there is some correction factor available. That correction factor is incorporated into the kernel's weights, thereby improving the kernel. So that is back propagation very simply, and this operation has to be continued. And the more longer we we train, the better the output will be. Right. So in the back propagation, there is a forward pass It's through which the CNN calculates the activation of neurons, right? And the error calculated, the ground truth is what we like. If I know it's an ear of a cat, and my model is unable to identify that image as an ear of the cat, then it will then I mean, what we are saying is that what we're saying is the ground truth, and what it finds is the inference. So if there is variation, if there is a discrepancy, then there has to then we have to percolate that error back to the system. Okay, so this is basically a diagrammatic representation. Maybe this can help you. So this is an input. There are filters. There is an output, and the error has percolated into the system. There is a feedback system wherein that error is put back into the error is calculated, the correction is calculated and put back into the system. Now there is like I was talking about loss and I mean errors. So we'll talk about loss and accuracy. Accuracy basically means what we're talking about is there is error. Therefore, the higher the error, the lower the accuracy. Accuracy is basically a percentage. When we are trying to minimize this error or maximize the accuracy, right? So see in the left diagram, model accuracy over time it increases. So that is our objective and or aim. And accuracy and loss is just not the opposite. It's not a percentage. It's a function. Um, I would say, yeah, like it takes into account, possibly this statement is very good one. It takes into account the probability or the uncertainty of a prediction. So that is that is the thing. Like it will calculate uh, like it basically we use this for to understand how much my model is accurate, or maybe the term is not even right, like how good it is, how good is my prediction possibly. So that is it. Right, I should move ahead. And accuracy is like what I said. And I'll just enhance this relationship between loss and accuracy, that as accuracy increases, there is decrease in loss. But that is what our expectation is. And this would happen if it is, there would be a percentage. Both would be a percentage, but that is not the thing. Basically, there are different measures of our model. Right. So I'll just go back. See, more over time, we are trying to minimize our loss, but that always does not happen. Okay. So next part is epochs, batch size, and iterations. I would say like epochs is how many iterations we will give to the model. More number of iterations, better it is. So that is the epoch. So if we have 1000 images for training, that entire 1000 image, when it is moved through the network, one epoch is completed. And again, if when while performing that operation, we need to have a batch size. The batch size is like in how many batches will will in how many batches of say in 10 batches of images. So if I have 1000 images, and if I am if I am computing 10 images at a time, so there will be 1000 such batches, right? Okay, so let me move ahead. I suppose these are other data, these are other information. I suppose I will not move ahead. This what I wanted to, this is actually part of my other slide. Basically, our CNN and the things that we need to control. See, there are epochs that need to be configured, or that we need to provide values, batch sizes, and iterations. Those are the things that we really to work, need to know while we are working with CNN. And about the rest of the part, rest of the slide, I'll give the slide. They are basically some information, but not, they're related, but will not be using while we are developing our solution. See, these are structured, unstructured, supervised, unsupervised learning. These are fitting, underfitting, overfitting, and generalization. And that ends my slide. But what I'm trying to say is these are a little bit theoretical in knowledge. And about underfitting and overfitting, I'll just like to tell you that our objects are none. I mean, underfitting and overfitting, neither of them is good. We definitely want to avoid all of them. So generalization is the right thing that we need. If I have the same image or very similar image in huge numbers while training, or that causes an overfitting, or if there is lack of some vital images, then that is again not a good thing. So those anomalies percolate into the system, into the model, and then we have some overfitting and underfitting. So we need to um, eliminate them, and there are techniques for doing that. We need the right amount of training images, the right with orientations, rotate them. So we need all those other things. Those are the things. These are the things that I'll, as a developer or as a developer of the solution of CNN, the problems that I face, we are that is what I can talk. That is what I'm basically telling. So with this, possibly, I will be closing this session. The rest of the part, I suppose, is just much theoretical. So, anybody, any question? Hello.
Yes, sir. There is one question in the question answer section.
Okay, yeah.
Definition of convolution operation from Ayush Datta.
From. Okay, okay.
From Ayush Datta,
Definition
sir.
of.
For participants, you can ask the question and you can post the questions
Yeah,
in the
yeah, yeah.
chat box or
Just
in
tell
the
me the
question
question.
answer section.
Okay. So, okay. So definition of convolution is, see, basically is like convolution. It's a dot metric. It's a dot. No, okay. We have a input image or a 2D matrix input and a 2D filter, and it's a dot product between them. And that input, we are convolving. Basically, we are moving the our region of interest over the input image with certain strides. So that is basically a convolution operation, right? Hello. I'm not sure if I'm really audible or if the network connection is good. Hello.
There are one more questions coming
Okay.
in the question answer section. Sir, question is from Subranil Ghosh.
Okay. So how we can calculate the different values of RGB filters? RGB filters basically, like I told you, it's not always that we need to calculate the different values of RGB filters. They will start off with some values, arbitrary values, although we can control the values, but the values are still arbitrary values. Uh, our main purpose of this entire CNN or training is to get the correct values of the filters. That is the reason why we are performing the training. So we are not calculating the values ourselves. Our CNN, that our training module, or our training phase, that will calculate the exact values we need to identify the features. So it's not that we are doing it, it's our system that is doing it for us. Okay. Hello.
Yes, sir. We have few participants who have raised their hand. I think they have some questions. So we can, if you give the permission, we can allow him. Sumdata ma'am, are you there?
Yeah.
Ma'am, your voice is not audible, ma'am. Hello?
Yeah.
Ma'am, we are not able to hear from you, ma'am. So, ma'am, if you give the permission, we can allow a few participants to ask the questions. Ma'am, we are not able to hear you. Ma'am, we are allowing Debadrati Das. Yes, ma'am. Debadatri Das, please unmute your mic and please ask your question. Debadat Debadarita Das, unmute your mic. Debadarita Das.
Am I audible?
Yeah, I can hear you.
Yes, ma'am. Now
I'm
audible.
audible.
Yes, ma'am.
Yeah,
Yes,
ma'am, I can hear you.
Debadrita Das, are you there? Please unmute your mic.
Devadrita, you can ask your question. Okay, we have Shanti Chakraborty. Yes, you can ask. You can ask. No one is audible.
Sayanti Chakravarti, please unmute your mic and please ask the question. You can ask the question. You have unmuted your mic.
Are you there? Obhik Chakraborty, Obhik Chaudhuri, you can ask. You can unmute yourself and ask. Are you there, Obhik Chaudhuri? Is there any problem regarding the audio? We are not able to hear anyone.
Ma'am, it is audible, but I think the participants have not unmuting themselves. So, so participants, you can post your question in the chat box also or in the question answer section. If you are not able to ask your question using the mic option, you can post your question in the chat box also. Ma'am, Sayanti Chakravarti has asked the question in the question answer sections also. It is already removed there.
Well, I guess we do not have any more questions.
Yeah, okay, I believe so. Okay, I just uh, there is only one question in the question answer section. I answered that. Another one was asked, so I also answered that. maybe they have some problem, technical problem. Anyways, ma'am, so it was good to be part of this presentation.
Yes,
And
yes.
I believe if you have, like, if I could help, or if my presentation was good. So, anyways, thank you for this
Yes,
opportunity, and thank you all of you for all the participants. So,
yes. We also, on behalf of CDAC and MAKAUT, we thank you for your deliberation on this topic. We are really grateful to you for having you here, that you have spared time from your schedule and you are with us to share your experiences. We thank you very much.
thank you, ma'am. Thank you, all of you.
So we can move on to the next
Yeah.
speaker. Uh, is he here?
No,
Yes,
ma'am,
yes.
not joined, ma'am. We can ask Hina, ma'am, whether sir will be joining or not, if possible, ma'am. Lecture session 2 will be starting very soon. Please stay connected. Our eminent speaker will be joining very soon. Session 2 will be starting very soon. Please stay connected.
Yes, I request all the participants to please stay connected. Uh, the second speaker is having some problem connecting. So let us please wait a bit. And let me announce that after the end of the session, you will be having an online test. The link will be given to you in the chat box, and you will get about half an hour to answer the questions. You will have MCQs, and you need to answer them. And the answers will be given automatically. So please stay with us till the end. The second speaker is having some issue regarding connection. So that is why he's taking time.
Ma'am, Ankur sir is joining.
বলো একটু বলো লেট হয়ে গেছে বিকজ অফ দ্য নেটওয়ার্ক ইস্যু হ্যালো জোরে বলো এটা ভলিউম বাড়িয়ে দাও এই তো এটা বাড়াও না এখানটা বলো আরে ইয়ে দিয়ে বাড়াও মাউস দিয়ে
Welcome, sir.
প্রেজেন্ট শেয়ার হয়নি এখনো স্ক্রিন আগে কথা বলো
আচ্ছা good afternoon everybody
Welcome, Mr. Ankur Ghoshal.
there is a little bit delay due to technical issues. I beg your pardon. Uh,
We welcome you to the final day of the workshop. So in this session, this is the final session where we have two speakers together, like they will be presenting the same content. We have Mr. Ankur Ghoshal and Mr. Rupam Mukhopadhyay together. So before we invite them for the deliberation, I would like to briefly give an introduction of both. Mr. Ankur Ghoshal, he has more than 8 years of relevant experience in the field of image processing, pattern recognition, and machine learning. He has developed and tested software modules using best practices in C hash, .NET, and Python for various user agencies. He is currently associated with CDAC as project engineer. And I would like to introduce Mr. Rupa Mukhopadhyay as well. Welcome, Mr. Rupa Mukhopadhyay. He has more than 13 years of relevant experience in the field of image processing, pattern recognition, machine learning. He has designed, developed, and tested software modules using best practices in C hash, .NET, and Python for various user agencies. He is currently associated with CDAC as project engineer. I request you both to please initiate the session.
okay, thank you very much, madam. So today our topic is about artificial in Python for artificial intelligence or machine learning. Can you able to see my screen?
Yes, sir, it is visible, sir. Please make it in full view mode.
So today we actually we will try to explain about the different examples, using different examples, how to basically set up Python environment and virtual environment for running different machine learning applications in Jupyter Lab notebook. And by the end of the lecture, we will give 20 Python open source project some names, which will be which actually is available in GitHub for further reference. So basically, what we're trying to say, I'm just giving a little bit intro about AI and ML. Basically, the difference lies in machine learning and the AI is the approach the machine learning deals with. So basically, when the machine learning comes, topic comes, it says about the data. If there is some, there are some data sets, and we have to find some common pattern and nuances from those data, then we need to use machine learning algorithms. So basically, why Python is best for ML? It is very much fond language for machine learning community. Why it is? There are various reasons. First of all, it is very much easy and congruent, and there is less involved coding required, because there are so many packages available in Python like NumPy, SciPy, scikit-learn, Keras. Those are available in Python, and they are equipped with so many machine learning algorithms. And also there is a there are various community and forums where various real-time Python applications for machine learning has been created. So that is also one point. It is also platform independent, and there are various visualization option. One is matplotlib, which helps to helps to see different kinds of chart for machine learning.
Uh, next, we want to say that how to set up the Python interpreter. I have actually depicted for Mac, Windows, and for Ubuntu also, Linux also. There are various steps for installing Python interpreter. Actually, we have for our applications we use Python 3.7.3 because Python 3 is the first choice, and future will application will also use Python 3 because so many applications are built upon this. So basically, after installing Python, there is a popular package manager in Python which is pip, Python package manager, which helps to install other packages required for different algorithms. Um, Next, we will talk about virtual environment. Virtual environment helps to isolate the runtime in overall runtime environment from other environments. Like if we want to install some packages in Python, then if we just simply use pip install package name, then it will be installed for overall all the packages, all the virtual environments. But if we install virtual environment, then it helps to isolate those packages from the system so that whenever required, this virtual environment will be popped up, and those after virtual environment comes, we can run the code and all these things. Even if there are some issue, one can delete the virtual environment without affecting any other packages installed in the system. So I will just brief upon the Jupyter Lab notebook, which we are currently using, because this kind of notebook is very much helpful for academicians, and also some showing some presentations, because it helps to code as well as depict some text. Visualization things are very much easy in a notebook. Jupyter Lab is the next generation web-based interface for Project Jupyter. Jupyter was already there, but Jupyter Lab is fast. The GUI portion is very much sophisticated as compared to Jupyter. So basically, for our examples in machine learning, we require require various packages that I have mentioned in the slide. Those are NumPy, SciPy, scikit-learn, Pandas, TensorFlow, Matplotlib. So basically, we can say the machine learning workflow as this. We get some data from some sources, and after getting those data, we need to clean those data. Means if there are any kind of noise are there, if non-availability of data are there, then we need to introduce some pre-processing steps. If there are various other data also, like categorical data, we need to encode those categorical data using dummy variable. And there are other steps like standardization. Those are required for various algorithm before proceeding to train the model using those data. Then comes the training the model. After the data is prepared and it is in correct format, it goes to the training phase. In training phase, actually, what happens, those various algorithms try to fit the model over the data, and give us some parameter or values, those actually needed for the testing of the other data. And after that, the training, the more test data comes, and testing, after testing is performed, the different matrices like accuracy and other matrices are calculated, and based on that decision, we need to improve upon the model, or need to focus on the data, so that the model improves. Here I have shown some example of the data, like it is a retail data. There are 4 columns. 3 columns are for the independent variable, and the last column is the purchase, which is dependent variable. So this kind of data, there are, you can see there are some data in salary and age which are not there. We need to fix those values using pre-processing. What we can do that, average out all the data, available data, and put it there. There is one way, and there are various ways. Like this, we can pre-process the data, and we can normalize also those data. After the data comes in our hand, we can feed the different machine learning algorithms. Basically, here we depicted different categories of machine learning algorithms that are available. There are supervised learning, unsupervised learning, reinforcement learning, and supervised learning can be further categorized into regression, classification problem. Unsupervised learning can be categorized into dimensionality reduction, clustering, and all and other. Here we actually focus on supervised learning and unsupervised learning approach. In supervised learning approach, we will give some useful examples using for regression, classification, and unsupervised learning. We will see some example on k-means clustering. So So I want to ask some time before, after going before going to the demo of the programs which are available with us.
Yes, sir, Sundata ma'am.
Yes, yes.
Ma'am,
What were you asking? Ah.
sir is going to have some demo, so he wanted few seconds to work on it.
Excuse me, can you able to see my screen?
Yes, sir, it is some command window, sir.
Okay, okay. Thanks. Well, please give me some minute. I am going to show you the demonstration. So mm, basically what we are trying to do is we are activating the virtual environment as we discussed in the previous slide. This virtual environment already we have installed in our system, and the virtual environment is, the name of the virtual environment is env1. The name of the virtual environment is env1. Now we are in the virtual environment of the Python. If we want to see what are those packages which are installed inside those virtual environment, we can see using the command pfreeze. Those packages are installed. uh, I have already shown in the previous slides the different packages needed that can be installed using the Python package manager pip. After entering into this virtual environment, what we need to do is we have to up the Jupyter Lab notebook where our code is resides. Before that, we need to change the directory to the source folder. Now we will spawn Jupyter Lab notebook in the source directory where the source files are residing. This is the web application of Jupyter Lab, which sometimes required to up for this Jupyter notebook. So basically, we divided our examples in four stages. Basically, we can say four types of example we will show. Here we will focus on regression, classification, and also clustering. In class regression, we will show simple linear regression example for use for using we are using the data of some salaried persons. Those data are available with us. We will try to predict the salary based on some features available. Yeah, here those are the data. You can see the independent variable year of experience and the dependent variable salary, and yeah, we collected those data, and we want to predict the salary of a unknown person based on the year experience.
But before going into the demo, I want to show you, tell you why we are using this kind of algorithm. The machine learning, I think you already know that. The basic difference between why we go for machine learning. When we have some data and we want to uh, draw some reference from those data, we are using machine learning, and where we cannot have the direct algorithm for developing those things. For example, in our cases, we have some, suppose the organization want some kind of policy where he can offer his employees, newcomers, how much salary they can offer. So yes, they have some kind of data here. You can in the screen we can see that for 1.1 years of experience, the guy can have 39,000 salaries, or 13 years. This kind of data we have. Now the company wants to draw an inference from this data. So the inference is like that: when a new employee came into the organization, when he just put the experience, the model will tell us what salary the person can be offered by the company. So this application is going to be demonstrated by Ankur.
So as Rupamda pointed out, here are those data. We want to predict the salary of a person based on his her experience. So basically what we are trying to do, we will first of all import those packages required for our algorithm to work. Here are those packages like NumPy, Matplotlib, Pandas. These packages are required for running this application. Then we will actually we are importing the data from the CSV file, as I have already shown. The data sets we are partitioning based on the independent variables and dependent variable. After that, we are splitting the data into train and testing. 1/3 of the data we are giving for testing and 2/3 for test. Then what we are trying to, we are importing the class called linear regression from the very popular package called scikit-learn, available in Python, from where we will try to fit our training data and try to predict out the testing data. We are here actually basically we are trying to feed the training data. After fitting the training data, we are predicting on the test data, and you can see yeah, after predicting, you also can visualize here. Actually we are showing the red dots are actual data for training, and the blue line is the best fit line for the data. This is for training. And for testing, we are also trying to show whether our best fit line actually can give best fitting result for the test data. If there are any kind of mistakes are there, that is also depicted using this graph. Here red dots are the actual test points and the blue line are the predicted line in training phase. And here we can also calculate the coefficient and the intercept of this line. After that, what we are trying to show, we are trying to judge our actually the linear regression algorithm based on some parameter like R square, metric R square and adjusted R square. R square actually tells how much the base fitting line deviates from the mean prediction. If we consider, if there are no prediction algorithm available, we can best predict the value of a salary of a person based on the mean value of the salaries available. Uh, basically, we are trying to calculate R square, which tells if R square value is close to 1, then it tells that our predicted line is far better than the average line. If it is close to 0, that means we are approximated as like average line. Here we can see that R square and adjusted R square value is close to 1, 0.97 and 0.9767. So it is the example for simple linear regression. Here one independent variable is here. In the next example, we will see multiple linear regression. Here, the data, you can see the data of 50 startups and their profits based on some input parameters like R&D spend, administrative spend, marketing spend, and their state. These 50 startups profit values we are trying to predict for using multiple linear regression. The process starts the same. First, we have to import the required packages. After importing those required packages, we need to import the data set like 50 startups.csv. And here also we are partitioning the data. Basically here the ilog function, what it actually doing, it is partitioning the input independent variables from the data, and y is also partitioning the only the last column, which is the dependent variable. After getting those partitioning those data, we are now actually there we can see some data are categorical data. The column state, it is a categorical data. So we need to transform this column using one hot encoding. What is one hot encoding? What one hot encoding tells if there are an n number of categories, then for n the n number of categories, for n number there will be n number of dummy variables, and for each category only one category will be depicted by 1 and other will be 0. Like here you can see there are three states: New York, California and Florida. So there are 3 categories. So here there will be 3 dummy variable, and those dummy variable only one at a time will pick up value 1 and others will values will be 2, values will be 0. So after encoding the data set, we are again splitting the data into train and test. We are splitting the data 20% into test set and 80% for training. Here the same function linear regression is used, and we try to fit the data set using linear regression. And next we will actually fit the line. We want to predict the test data using our base predicted line. And here we can see uh, I have shown in 2 columns. Left one is the predicted one and right one is the actual one of the test data, and you can see those values are close enough. So if we plot the data, actual data and predicted data, here the graph shows, and the red dots depicting predicted value and green dots are for actual value. We also calculate here mean square error. Here you can see the mean square error is high because uh, there are some data is quite apart from the actual one. There may various reasons of that. Maybe some noisy data are there, or insufficient data. uh, After if the data is in proper way, means if the noise is not present and sufficient number of data are available, then the prediction model works well. So this is actually these are the 2 examples of linear regression problem. And next we will go to classification problem. Classification problem, first example we will see logistic regression. So classification problem, as you can, you have already know that classification problem deals with the categories, and regression, as we can see, the real value prediction problem. Classification, the logistic regression, here with the data we are using social network data. Actually, the data shows some of the company who want to personalize his products for their customers, and they have those data like age and estimated salary, and based on these parameters, whether the customer will buy, purchased or not purchased. These previous historical data they have in their hand, and they try to predict whether new customer with some X age and Y estimated salary, whether he will or she will purchase the personalized those product or not. So the process, as in linear regression, first of all, the importing those libraries and importing those data, then we are doing feature scaling. Here feature scaling is required. We are doing because there are various independent variable and their ranges are different. Like in case of salary, their ranges in thousands, and in case of their ages, they are basically 2 digits. So their scale mismatch, so we need to scale them in their normal, we have to normalize them in a proper scale so that uh, uh, the model actually works well. And after normalizing those data set, what we are trying to do is we are using the logistic regression class, and in logistic regression we are trying to feed the training data. And here we have shown a single example whose age is 30 and the salary is about 87,000, and whether he or she will buy his product, we can see that he will not buy their product. The next we can see we are predicting the test results based on the based on the model we have just fitted over the training data. After getting the results, we are calculating confusion matrix of the data sets. Here you can see the matrix. It is giving only 39% accuracy, because maybe there are some noise available in the data and insufficiency. This restricts the model for predicting better results. Next, we will just uh, visualize two classes, whether left one is whether he or she will buy, or green class whether he will not buy. And you can see there are some points in red dots which are in the green lines, and some green points which are of the red lines. Those are misclassified points. And here also we can see the test results like this. So in our classification example, we will next see naive Bayes classification. Here I just want to brief one thing, that why actually this classification model we can broadly classify it into discriminative learning model and generative learning model. What we have seen in logistic regression, this is discriminative learning process, because here we were actually predicting the discriminating boundary between the classes. But in case of generative learning, what it does actually try to fit this probability distribution of every class, and their parameters are calculated, and based on the distribution, if new data comes, then it try to predict whether these new data belong to which kind of distribution. Naive Bayes is a kind of generative learning model. For naive Bayes, we have actually the process is same, that we are importing the package, we are importing the class, then we are splitting the data. Here 25% we have given for testing and 75% for training. The advantage of naive Bayes algorithm kind of over other algorithm is that it works well with small data, because you can see that in discriminative learning process, as the data size increases, the discriminating boundary is very accurate actually. But whenever the data size is small, the discriminating boundary is not so accurate. But in naive Bayes, it is not actually depicting the discriminating boundary, it is depicting the probability distributions of different classes. So it is for small data set, it also works well. Next process is same. We are scaling the features in a in proper scale. Then we are using Gaussian naive Bayes for predicting for fitting our training examples. And as new example is here, we are also are able to predict the outcome. So here what I will show that here are the test results and the confusion matrix. What I actually want to show you that the confusion matrix here we get the 90% accuracy. Here the data set size is very small, but it is giving quite high accuracy. And if we want to see the graph for the boundaries actually for the two classes, we can see this the boundary is kind of nonlinear boundary dividing the two regions. And here we can also see for testing data. Yeah, you can see that there are very few points are misclassified as compared to logistic regression. So in classification, our next algorithm is artificial neural network. And here the data we are using some bank data, whether they are modeling whether their customer stays in the bank or they will leave based on some certain parameters like their credit score, geography, gender, salary, etc. And in artificial neural network, the first two processes are same, importing the packages and importing the library. Here TensorFlow, the well-known product of Google, we are using for artificial neural network. And here you can see that we need to pre-process this data because you can see there are some data like uh, gender, geography. Those are actually geography, gender. Those are categorical data. We need to first make in a proper way. We have to encode those data. After encoding, we need to pass this data for training. So basically, we are doing this thing here. We are encoding the geography and as well as the gender. And next, after encoding the data, we're actually what we are doing. Splitting the data into training and test set as we have done earlier. And then we are feature scaling the data. Next, we are actually building a neural network, sequential neural network, where the input layers are actually, here you can see there are actually total 14 columns, but there are some columns which are not necessary, like the row number, customer ID, surname. These are not required for predicting whether he or she will live. So we are not considering these columns, these three columns. And after those columns, like from credit score, geography, gender, we are considering for our prediction model. And likewise, we are making a neural network architecture where the input nodes will be of the number uh, uh, input nodes, and there are two hidden layers. In hidden layers, there are six nodes each, and the output layer is only one node, which it says whether they will customer will leave the bank or not. After making the artificial neural network, we are making actually we are using Adam optimizer and different parameters there for to compile the artificial neural network with the data sets. And as you can see, when you will fit the data and using batch size means if the data sets is huge, then we need to partition the data sets into batch sizes of 32, which will run on different cores if there are multi-core processor. And epochs means total how many times it is covering the whole data set. So 100 times it is covering the whole data set. So after running the fit function of the artificial neural network, we have actually, you can see the accuracy is near about 86% for training data. And here next we are trying to predict with a single example whether it can what it tries to predict. So based on the single example, here you can see that the person will not leave actually. Now we are predicting the test result, and after predicting the test result, we can see the confusion matrix, and the confusion matrix here you can see that it is 86%. It is less than the naive Bayes, but it is quite good as compared to logistic regression. So we have only here we have only 3 classification example, and I will show one clustering example, and that is K-means clustering. This is a kind of unsupervised learning approach where labels are not provided. As we have already seen in the classification example, the labels means the dependent variable are given. Here, the only independent variables are given, and we need to cluster those data so that anytime the next data comes, which can fall in any of those clusters. So the process is the first two steps are same: importing the packages and then importing the data set. Here you can see that X is only there, Y is not available. And then we are using elbow method to find optimal number of clusters. You know that in k-means we need to give the number of cluster. So here the elbow method is used, where you can see the better cluster, the separation of data is given in the joining point of the elbow. Here, like in 5, the 5 number of cluster is optimal based on this elbow method. And we are training actually after getting the optimal number of cluster, we are training k-means model on the data set and try to predict those clusters. And you can visualize there are 5 clusters, red, green, yellow, like this. And there also you can see their cluster points centroid. So actually, these are some examples that we have depicted. There are various open source projects available in GitHub. You can consult there. There are various communities and forums also there for getting some projects there in GitHub. So basically, we can say that machine learning is kind of astonishing powerful tool, and here Python enhances its capability by different kind of packages, as Python is free and open source, and there are various communities which are helping to make different kind of projects available in different platforms. It is growing day by day, and it will, and the machine learning, as the machine learning progresses, Python new version are coming, and this is equipped with different kind of features, helping developers, programmers in many ways to tackle different kind of pressing problems of machine learning. And here are those references we used for this presentation. Thank you very much for your kind attention. Any questions?
Yes, there are a number of questions.
Okay.
So is your presentation over? Like,
Yes. Yes.
okay. Ayush Datta, he has asked, I use Anaconda compiler. Is it relevant?
Yeah, it is. It is also a very good kind of package. It is actually Anaconda differs from this Python package manager. Is that Anaconda already equipped with so many data science libraries like Pandas, NumPy, SciPy. Those are available in Anacondas. You don't need to install those, and you can use those packages. Okay. Next.
I think about Anaconda only, Ayush Datta, the same person has asked, is it appropriate for machine learning and artificial intelligence?
Yes, yes, it is actually because there are so many packages we need to consider upon installing. But in Anacondas, they have their in their mind, and those are the packages required for machine learning and data science. They have already pre-built in with this Anaconda. Now you can also install it.
Okay. He has again asked, I cannot understand predicting test result. Maybe you can directly ask Ayush Datta. Can you please let him in? Ayush Datta. He can directly ask what he cannot understand.
Yes.
Yes, please ask.
Hello, sir.
Yeah.
Sir, you can sir, I can understand. I cannot understand, sir. This PPT predicting test result. Kindly,
If there, I have shown
sir, I
you
am
the.
here. Hello.
Yeah. Can you hear me?
Yes, yes, sir.
Yeah, actually, I have shown here some examples of regression and classification. And regression, there the real value problem. Actually, it is trying to kind of predicting the real value. Means suppose you have some year of experience and try to predict the salary you can get from any company. It is kind of a regression problem. And the classification problem, it is kind of classification, means categorize whether you will buy kind of some product or you are not going to buy some product. So in test results, what we are trying to do is that we are trying to fit in, if we are considering the regression problem in training, we are trying to predict the, in linear regression you can see that we are trying to predict the line out of it, so that if the training data vanishes, then also we can predict the new data based on the line. if two dimension, you can see that if you put x point, and if you draw a normal out of it, and you can see any point on the line, you can definitely get any point on the line. This is kind of approximating your testing data,
Okay,
right?
sir, is it a part of data science?
Yeah, kind of. Data science is basically application oriented, we can say, and machine learning is kind of theoretical approaches, those algorithms, and using those algorithms, you can do whatever in data science. Data science kind of application and machine learning kind of theoretical aspects are there.
Okay, okay, sir. Thank you, sir.
Another question, what is the meaning of random state while splitting the data?
Okay, here random state actually means we are actually uh, dividing the data based on randomization. But for this example, we are actually fixing the random seed. Here random state means random seed. The random seed, if we are not fixing there, the randomization function, it will give different kind of test data and trend data in every time we run. So here for this example, we are fixing the random seed. In your example, if you want to try multiple times, then you do not have to freeze the random state. You do not have to mention the random state. Here for example, I have mentioned because we are running the next example for one time, right?
Okay, thank you. Deepamita Ghosh, you had raised your hand. You can ask. You can allow Deepamita Ghosh. Yes, what happened? Any other question? You can raise your hand. Fine, I think there is no more question. We have answered the questions that were there in the question and answer box. So I think we have reached the end of today's session. There are no other questions. I think we can, even if you have, then you can write them down in your in the link that we have provided you in the discussion blog that we have provided you. There you can write your questions, and we have shared it with the experts, and they can answer. Even after the session ends, they can answer. So, so I think on behalf of all of us, we would like to thank Mr. Ankur Khushal for his deliberation, for his presentation, for his hands-on demonstration. I hope a little bit of practical demonstration was also required in this particular workshop, and you have helped us. Mr. Srimanto Pal, he has raised his hand. Can you please allow him? Yes. Let us see.
Hello, ma'am.
Yes, please ask.
Ma'am, I'm just asking the mock test you tell some before. When
So if you have any question, technical question from our expert, you please ask.
no,
Otherwise, We will announce about the test. We have already announced, so we will let you know. If you have any question from our expert, do you have any question to ask?
No, ma'am. No, ma'am.
Srimantapal, if you have any query related to the session, you can please ask here. We are here supposed to get the questions only for the technical part. You want to know the
No question, sir.
Okay, thank you. Thank you.
Okay, okay. Thank you.
Okay, sir. So no further questions, and I think we can thank you very much for being with us, Mr. Munkul Kushal, for sparing time. And it has been a very good demonstration. And I think many of our participants who are already doing machine learning with Python, they have a little bit of experience also. So maybe you can try and practice. And if you have any further query, you can ask our expert. He will surely help you. Okay, so thank you so much. And so to proceed with the session, we have reached the last lap of this workshop. And as I had mentioned before also, we will be taking an online test for our participants. The link has been provided to you in the feedback. I think it has been provided in the chat box. So once we close this session, you will get a time of half an hour or 30 minutes, and you will have to answer the MCQ questions. After which, can you tell me, Prem Kumar, when they will be getting their certificates?
yes, ma'am. By today evening only we can provide the certificate, but mandatory is to give the test.
The test is mandatory for each, and the certificates. How will they get their certificates?
We will be mailing them.
A link will be provided, I guess.
We will provide the link after the submission of the test. Yes, ma'am.
After you submit your test, you will get the link for certificate generation, and you'll get it by today evening. Okay. So thank you all for your participation. It has been a very good and interactive session throughout the week. And we will be further having such type of sessions in near future, where we will be focusing more on hands-on and demonstrative workshops, where real life projects will be demonstrated, and maybe on Python or R, the project demonstrations might be done, or hands-on sessions will be done. And we would all like to invite you all, if you, as you have interest and you have gained some basic knowledge on AI, in this workshop, the next workshop will be a little bit more advanced, and we will focus more on hands-on. And I would request all of you to participate in those workshops also. And so we can work together as a group, where we can focus on projects based on AI jointly, the university and CDAC. So with this, we end today's session, and I request you all to please get ready for the test. The lecture notes have also been provided to you for further reference, for future reference. All right. So I think I request the host to take over now. Whatever announcement you have, you can make.
Ma'am. Ma'am, as you have told that the test will be open after the end of this session, and it will be active for half an hour. And for any questions, it is available our discussion forum, so that they can post the questions, and there are our expert who will be giving the answer. And for the lecture materials, as many participants have questioned that they need a lecture notes, so as we have now uploaded the lecture notes in the drive, so the link has been shared. And ma'am, the certificates will be distributed after giving the test, that is by today evening. So it is requested to all participants to kindly take the quiz, and please note down the lecture materials for the further reference. So, ma'am, Ma'am, if you give the permission, we now may close the session, ma'am. The quiz will be active for half an hour, so it is requested to all to kindly take the quiz. Please take note of all the links: the test link, the discussion forum link, and the lecture materials link. We are uploading the lecture materials in the drive, and you can able to download all the lecture notes